got hit by a car today. Kids these days. But guys, I had an epiphany. What if we suppose the x velocity of the car at any time is given by the equation?
To find the change in x velocity of the car in the time interval t sub 1 equals 1.0 seconds to t sub 2 equals 3.0 seconds, you treat the equation as a function. Then write the equation v3 minus v1 equals 60 plus 0.5 times 3 to the power of 2 minus 60 plus 0.5. After that, just solve it as such, then voila.
So I need to go faster!
Newton is for another day. Now move along.
The average x acceleration can be solved when you take the change in velocity, shown as delta v, and divide it by the change in time, delta t. Fortunately, we already solved for the delta v, which is 4 meters per second, and the delta t is simple math, 2 seconds. So 4 meters per second divided by 2 seconds is 2 meters per second squared.
Instantaneous acceleration? Don't you need a change in velocity? Well, yes, and there's calculus. Math made of magic and rainbows in an enchanted forest. When you know that acceleration is the first derivative of velocity, you can look for a v prime of t formula. Doing the power rule, you can turn vx equals 60 ms plus 0.50 ms squared times t squared into at equals 2 times 0.5 t, which is simplified to just t.
But what is time? T sub 1 equals 1.0 seconds taken delta t equals 0.1 seconds.
Just add 0.1 to 1.0 and you get 1.1.
Oh, okay.
So, we have the equations and the numbers. Let's fill the blanks in. All these challenging calculus and algebra has finally built up into the final question, the ultimatum. It's pretty damn hard, so I highly recommend you keep your eyes with every single step done. You can pass Physics 12 simply by mastering such an equation. Ready? Pause the video if you need time. Alright, first we have to find the t's.
It's weird over there.
I found one.
But this really breaks so easily, and they were like, oh my god, look at this. It was like made out of jelly. So now the sikis were like, oh, this is indestructible. And then they get that, they're like, oh no, it's so loud, Nagi. The mother sikis is like,
found it. You found number 2.
Oh, yeah.
Show the teeth, man.
Now that we have the t's, we have to derive the acceleration equation.
Yep. That's it.